All right, welcome to the Explainer. Today, we're diving deep into a technology that's going to power the next generation of absolutely everything, from mind-blowing augmented reality to AI-assisted cars. We're talking about computation offloading, and this whole explainer is based on some really cool research out of the Eindhoven University of Technology. So let's just jump right in. Have you ever wondered why your phone, your brand new, super expensive, top-of-the-line smartphone, still kind of chokes on those really futuristic ideas? You know, things like a flawless, real-time holographic call with a friend, or an augmented reality experience that feels totally real. I mean, you've got all this insane power in the palm of your hand, but it's just not quite there yet, is it? Well, it all comes down to two major roadblocks. Two enemies of performance, really. The first is latency. That's that annoying delay you get when you ask for data and have to wait for it to start coming back. And the second is just a hard truth. The little computer in your pocket, as amazing as it is, has its limits. So to get to that next level, we need a whole new game plan. And that new game plan, it's all about changing where the heavy lifting, the actual computing, gets done. And this brings up a huge choice between the old way of doing things, the centralized cloud, and this newer, much faster idea called edge computing.
Okay, think of it this way. Mobile cloud computing, or MCC, is kind of like a giant central superlibrary. It has unbelievable power, endless resources, but it's physically located far, far away. So sending a request and getting an answer takes time. On the other hand, you've got multi-access edge computing, or MEC. That's like having a small, zippy little library branch right on your street corner. It might not have the same massive collection, but because it's so close, it's incredibly fast and responsive. And if you want to see the nitty-gritty, this table from the research paper lays it all out perfectly. The cloud is centralized. It has enormous computational horsepower, but you pay for it with high latency because of that distance. The edge, though, is distributed all over the place. It's close to you, which means you get that super low latency, but the trade-off is that each individual server has more limited resources. So just to be super clear, multi-access edge computing isn't here to replace the cloud. Not at all. It's actually creating this brand new middle layer. It's a whole network of small but powerful servers that are way closer to you. Think like at the bottom of a 5G cell tower. And their whole job is to slash that data travel time.
Now, having this new layer in the mix means your device constantly has to make a critical choice. When a really tough job comes in, what's the smartest, most efficient way to get it done? This is what's known as the offloading decision. And that decision process looks a little something like this. Let's say your phone needs to process some complex AR graphics. It has options. It can try to muscle through it all by itself. That's local execution. Or it can zap the task over to that nearby MEC server for a super quick turnaround. Or if it's a really massive task that isn't time sensitive, it might just send it all the way to the big cloud servers. So it all comes down to three basic moves. Any computation offloading system has to pick one. Number one, just do it locally, right there on the device. Number two, full offloading, where the entire job packing to a server. Or number three, and this one's clever, partial offloading, where the task gets split. Your phone does part of the work, and the server does the rest. Yeah, but here's the catch. Making that call in a fraction of a second, it is anything but simple. It's an incredibly complex balancing act with a ton of different factors all changing at once. And hey, you don't have to take my word for it. The researchers who wrote the paper put it very plainly. Making these kinds of perfect decisions in a 5G network that's constantly changing is, and I'm quoting here, not trivial, which, is basically the scientist's way of saying it's ridiculously hard. So what makes it so tough? Well, it's a puzzle with pieces that are always moving. You have to think about task dependability. Like, does task B need task A to finish first? Then there's resource allocation. Who gets the precious bandwidth? And what happens when you're in a car, zooming from one cell tower to the next? It's a huge challenge. But, solving these massive challenges, that's exactly how we unlock what's next. As we start looking past 5G and into the world of 6G, this skill, this ability to intelligently shuffle computing tasks around, is going to become absolutely essential.
I mean, we're talking about applications that need a response time that's basically instant. Real telepresence, mixed reality that blends seamlessly with our world, and self-driving cars that have to make life or death choices in a split second. None of that can happen without incredibly smart and efficient edge computing. And believe it or not, it doesn't even stop there. The next evolution is something they're calling far-edge computing. The idea is to create a computing continuum, pushing resources even closer to us, almost weaving them into our environment. This drives latency down even further, and because your data travels less, it also boosts your privacy. And speaking of privacy, this whole distributed network makes amazing AI techniques like federated learning possible. This is a total game changer. It lets AI models get smarter using data from all of our devices, but without our actual personal raw data ever having to leave our phones. It's smarter AI without the security trade-off. So if there's one big thing to take away, it's this. We're shifting away from a world where computers are just in big central places. We're moving to a world where computing power is all around us, distributed everywhere. It's a fundamental change that's going to completely rewrite the rules of what's possible. Which, of course, leaves us with one last really big question. When computing power is woven into the very fabric of our world, what reality are we going to build next?